So in the last video I mentioned using the terminal to simplify the input process. And I'm going to show you an example of some commands and how you'd actually run CrystoGen using the terminal. So you've got a few options depending on what operating system you're using. I'm currently using a Windows computer, so I can either use the built-in command prompt in Windows, or I can install a terminal emulator to give me an experience which is more similar to Ubuntu or Mac systems. I prefer using the latter example because a lot of supercomputers are based around Ubuntu architecture, so all the commands that you would learn to use on your own machine can also be applied to supercomputers or high-performance computing systems. So I'll show the Windows command prompt first. There's a quick way to get to it wherever you are in the computer and Windows. You can just type CMD into your address bar here, and it will load the command prompt in the folder that you're currently in. So a few quick commands that you need to be familiar with if you're using the command prompt. You can type dir, and that lists everything that's in your folder, or directory, that's what dir stands for. You can type cd space and then the name of a directory, and you will navigate into that directory. So cd simulations. If you don't want to type the whole thing, you can actually press tab and it will autocomplete. So if I now press dir in here, it will list everything that's in that folder. So if I go to that in my File Explorer window, you can see that I have the tutorial folder. So if I navigate into that tutorial folder and type dir again, it will list all the files that are within that folder. If you want to go back up a directory, you type cd ... and then cd ... again, dir. I'm now back in the same folder as my CrystoGen Executable. So let's say I wanted to run a simulation. First of all, I'm going to rename this to 3-barite tutorial so I don't overwrite. The command for running a program in the Windows prompt is very easy. You just type the name of the program. In this case, I want CrystoGen. If I press tab, it's actually selected CrystoGen.log as autocomplete. But if I press tab again, it will skip to the next one which matches, which is CrystoGen, the program. So if I press enter, it now runs the program the same as if I double clicked on the executable. So I can answer my questions the same as I did before, 0.5, 500,000, and I'll type color. And then it'll run the simulation the same as before. But you can see it's kept a graphic up showing that the simulation is finished, which we didn't see previously when running with the executable. So now let's switch to my preferred example, which is a terminal emulator. So if you're on an Ubuntu machine or a Mac machine, you already have this terminal. This is what you have instead of a command prompt. So all these commands I type here will be exactly the same as what you input in your terminal on your Mac or Ubuntu machine. So if you're on Windows, you want to install some software called Git Bash. So if I type it down in my search bar here, you can see I've got the software here. This also gives you access to Git, which is quite useful for version control. A lot of software companies use this. You may be familiar with GitHub, but there's a shortcut for opening it in the same folder, same as I did with the command terminal. I can just right click and say open Git Bash here. You have to select for that option to be installed when you install GitHub. So the commands are really similar between the two command prompts. The main difference is instead of dir, you type ls, which lists everything in your directory. If you have your terminal set up correctly, you can set a color scheme which lets you differentiate between different files or folder types. So you can see here that the CrystoGen executable is in green, and the directories or folders, simulations and structure files, are in blue. So the other commands are exactly the same as on the Windows command prompt. So cd simulations, and if I press tab, it will autocomplete. The main difference between the two systems is the direction of the slash. So terminals on Mac and Linux will use the /, and terminals on Windows will use the \. So if I type ls again, and cd tutorial, ls will list everything in the folder. So if I use cd ... again, it has the same effect. It takes me back up a directory. You can also type clear to get rid of all your commands if it's getting a bit messy. So there is a slight difference with how you run programs using the terminal instead of the command prompt. Instead of just typing the executable name, you have to actually type /, then the executable name. But before we do that, I'll show you another feature of the terminal, which is an inbuilt text editor called Nano. So you can actually manipulate your text files directly from the terminal. So if I type nano input.txt, it will open the input.txt file and I can edit it here. I have to use my arrow keys to navigate through the file, but all I'll do is I'll change the name of the simulation from 3 to 4 so it doesn't overwrite. Then to quit Nano and save, I can press Ctrl X. It'll ask, do you want to save? You press Y, and it asks you, do you want to assign it a different name? But I'll just leave it as input.txt. So it's now overwritten my input.txt. All I've done is change my simulation from number 3 to number 4. Let's run the simulation. So you don't always have to type the command in again. You can press up and down in your arrow keys to scroll through your previous commands. I didn't actually input the command to run Crystal Grower, so I will have to write it again. Press enter. And then I have to respond to all the questions again. 0.5, 500,000, and I'll say color again. It can get pretty tedious to keep having to input all those responses to the questions when you're running Crystal Grower. Especially, for example, if you ran with lots of periods of supersaturation excess, it can just take forever, and you can end up having to type in 100 commands for a single simulation. There is a way to mitigate that when you're using the terminal. As Crystal Grower is looking for parameters from input.txt as a text file, we can also feed in the answers to the questions Crystal Grower is asking us at runtime through a text file. So I know when I ran my simulation that I had to answer yes, no, 0.5, 500,000, color. Because I know that order, I can write a text file with those parameters in and just feed them straight into the program. So if I just make a new text file, and I'll call this add input.txt, and open it. If I type those parameters in here, so yes, no, 0.5, 500,000, and color, and then save this file. I can run that simulation, but then with the less than arrow key, feed in that text file as an input to Crystal Grower. If I press enter, it just skips through all of those questions and just runs the program. But that relies on you knowing the order of the parameters that appear. So for example, if I change my input.txt, I'll change my delta mu mode to 3 rather than 5. If I now try and run this simulation and feed those numbers in again, it's going to be feeding numbers into the wrong place. So even though the simulation started, it then crashed. And that's because it's feeding in the exact same parameters in the exact same order as it was for mode 5. So the response to question 3 here, which is over how many iterations should the equilibration period occur, the answer was 0.5. It's trying to equilibrate over 0.5 iterations, which is impossible. So once it gets to the point where it's going to try and equilibrate, it then crashed the program. So you have to be very careful here. So if I change this number to 100,000, which is what I'd normally use in this situation, and run that simulation again, then it'll run correctly and not crash. So you can see how useful this is to speed up running your simulations. In this case, it's a small gain because we're only inputting a few parameters. But let's try a more complicated example where we're inputting lots of parameters. So this time I'll run in mode 2. I'll set this as simulation number 5. And let's say I wanted a supersaturation excess. So let's run Crystal Grower without the input and just see how many parameters we'd have to input. So do you want molecules grouped? Yes. Do you want different weighting? No. How many periods of different supersaturation? So let's say I wanted 10 periods here. I would then have to define the ending point for every single one of these periods. So let's say 100,000. And then I'd have to assign my excess for each of my species in the system. In this case, there's only 2, but if I hadn't grouped my species together, I would have to assign 8 of these every period. So that's type 5 for barium. Then it'll ask when does supersaturation period 2 end, and I have to repeat this 10 times. But if I know the order that these appear, then I can type it into my addinput.txt and speed up the process dramatically. So let's cancel that simulation and actually do that. So we can change our addInput file now to match that long simulation we were just trying to run. We know that these 2 parameters were related to delta mu mode 3 and 5, and those don't exist when we're using mode 2. But we have all the questions related to the number of supersaturation periods. So we said we wanted 10 periods of different supersaturation. Then it asked us when did we want the first period to end, which was 100,000 steps. And then we had to assign our delta mu excesses for our components, our barium and our sulfate. We know we wanted this 10 times, so we can just copy this 10 times and edit them as we see fit. We know we wanted the first period to end at 100,000 steps, the second one at 200,000, 300,000, 400,000 and so on, until we reach our final period. The final period is slightly different because we don't need to tell CrystoGrower when it's going to end, because it just uses the number of iterations of the program to define the final period's ending point. So we can get rid of that line. You might be wondering what's the point of doing it this way, because we're typing all the numbers in anyway. This is going to save you a lot of time if you're going to run a lot of simulations that are similar to each other. And if you're typing in this many numbers into your command terminal, as soon as you make a mistake in your command terminal, you have to start all over again. So it's a lot easier to do it in a text file, make some mistakes, but then go back and change them individually. So now let's change these numbers slightly so we've got different excesses in each period. So let's change that to 3.0. I'll just assign some random numbers here so we get very different values in each period. Now that I've set up my rather complicated input, I can save this file and use it as an input again for CrystoGrower. So this time I'll run CrystoGrower and I'll feed in this addInput.txt file and press enter. You can see now that it's fed all those parameters in and it's just running the simulation. Now, for example, I realized that period 5 had an incorrect delta mu excess. I can just quickly go back and change that here without having to change every single other parameter in the file and type it all in again. And I can quickly just change that to simulation number 6 and then run the simulation again, feeding those parameters in. So it can save you a lot of time when you've got really complicated input procedures. This is also essential if you're ever trying to do any high throughput simulation using the terminal version of CrystoGrower, for example on high performance computing machines. I would highly advise going to learn how to use the terminal effectively. There's a free course on Bash scripting, which is what the Mac and Ubuntu terminals are based around, on Code Academy. It gives you a good run through a lot of useful commands. But 2 very useful ones that I find are grep. So grep will search for a term in a file. So if I search for nm, like nanometer, in a file, so I'll search within simulations tutorial, and I'll search in barite tutorial simulation parameters. You can see there's none in there. But if I search in barite tutorial simulation parameters 2, so you can see that it's listed all the distances between the facets in the crystal in nanometers. So these parameters are really useful for figuring out your crystal shape if you're trying to do a lot of high throughput calculations. And grep is the best command to strip this information out from your files. Whenever you run your simulation in color mode, this information is always recorded in your simulation's parameter file. Another command I'll also highlight is the sed command, S-E-D. This is the string editor command, and this lets you find and replace certain strings of text in your text files. So this command is incredibly useful when you're doing high throughput calculations. So you can use it incorporated into a loop to increment a single variable across a set of simulations. But I'll cover that in more detail in the next video. So just an example of how sed works. Let's say I wanted to change the word color in my add input file to find, I can type sed space apostrophe s slash, so that'll be the search term, so I'm going to search for the word color, slash the word that I want to replace color with, which is find, slash g. So slash g would just mean that it'll replace every occurrence in the file, and then another apostrophe. Then I have to give it the text file that I want to look at, which is addinput.txt. So if I press enter, you'll see that it just repeated the text file, and that's because I didn't actually add the flag, which tells it to edit the text file that's being used at the moment. So -i will now replace color with the word find. So if I go back to this file, it will give me a warning that it's been edited. If I press yes to reopen it, you can see that find has been changed. There are some other commands which perform the same function, so perl is another good one, P-E-R-L, but sed is already built into the terminal. So I mentioned loops briefly when looking at the sed command. If you're familiar with programming, you'll know that loops are a really powerful tool along with if statements. You can write these as scripts in the terminal if you know the syntax. So if I wanted to make a simple loop which counted from 0 to 10, I can write for I, where I will be my increment counter, in, and then I need to define a sequence to count from. So I'll use the inverted comma on the Windows keyboard and type SEQ, which stands for sequence, 0, 10. So it'll go from 0 to 10. Then I'll put another inverted comma and then press enter. Then I have to say do, because that defines that it's a do loop. Then I have to tell it to do something in the loop. So this is what's known as a for loop, where you define a condition for your loop to continue under. So in this case, I'll tell it to echo $i. So what that'll do is it'll echo the value of I, which is going to be increasing. And then I'll end the loop by typing done and pressing enter. You can see that it's incremented from 0 to 10 in steps of 1, following the sequence I defined in my loop. So that's just a crash course in how you use CrystalGrower with the terminal or the command prompt. There are a lot more advanced things that you can do if you get familiar with using the terminal. And in the next video I'll show you how to run CrystalGrower on high performance computing architecture. I'll be using Condor at the University of Manchester, but most HPC systems will have a similar setup and command system.